Hello, class. I wanted to do this video tutorial to help you not only with the virtual lab, but also writing your lab report. And so on your Moodle homepage, you have these links. So this is the virtual lab tutorial. This actually is needs to be completed in order for the virtual lab to be accessible. So make sure you do go through this virtual lab tutorial. Then you're going to click on the virtual lab. But before we get to that, there's some other things that I want to show you, the laboratory report instructions. And so I do want to click on that. And so I want to show you what you'll need to do in order to type up your lab report. Before for each of the different weeks that you're performing a lab, there's a couple of labs that you will not have to type up a report, but for most of the labs you will. And so I want to go through what you'll need to do for those. And so for these, this is the general format. So you'll have your file name, the type, it's a document, Microsoft Word document or PDF. It needs to be 2 to 3 pages of written text. And that does not include your title page, which needs to be a separate page, as well as your references that need to be separate. Then your font Times New Roman, 12 point, double spaced, a 1 inch margin. And then the orientation should be portrait. You're going to use the APA 6th edition for your references. And then your different sections. So you'll have your title page. That'll have your title of your laboratory assignment, your name, the course and section number, and the date. And then your introduction, your methods and materials, your results section, your discussion section, and then your references. And then there's some tips for writing a report. Very important that all your lab reports fall under these guidelines and that you have your lab report set up correctly. If you have questions as you're typing up your lab report, please let me know. All right. Then the other thing, the laboratory report grading rubric. This is the rubric that I follow when I'm grading your lab reports for Turnitin. And so I'm not going to go through them, but go through this and it'll tell you how I set up my grading for that. And then writing scientific reports, this is just a tutorial or help for you. All right, but we're going to actually go through the virtual lab. And so when you click on virtual lab, you have this virtual lab that appears in a separate window. And so what you need to do is you need to load an assignment. So we're going to go through at least the first step of the first lab assignment for week 1. And so you have the instructions on Moodle, and I'm going to show you that in a moment. But I'm reading from the instructions. And so you're going to go to the file like I just did and load an assignment. And then you're going to go to molarity and density. And then you're going to go to the metals density problems. So you're going to click on that. And so what you'll find is everything that you need to perform this laboratory experiment. And so you have your solutions, metals 1 through 3. You have unknowns that you're going to identify in this lab. Plus you have distilled water. And then in your glassware, you have Erlenmeyer flask at different volumes. You have your graduate cylinders at different volumes. You have your pipettes, different volumes, as well as a disposable pipette. Then you have your beakers at different volumes. You have your volumetric flask at different volumes. And then under other, you have a foam cup, a weighing boat, and a 50 milliliter burette. And then under tools, you have a Bunsen burner and a scale, okay, your balance. And so you have all of these different pieces of glassware as well as solutions and tools to help you perform the week's lab. And so what we are going to need, because I'm only going to do the first part, one example, so that you can see how we do this. So anytime you want to add something to your workbench, you simply click on it and you'll see that it's been added. It's going to add to this upper right corner. So I'm going to add the different things that I know that I will need to perform this first part of the experiment that I'm going to go over with you. And so, and all of this information I'm finding in the lab instructions. And so, just to give you a heads up of where I'm getting all this from. And it goes in the corner, so I like to move it over just so that until I get everything loaded onto the workbench, and then I move things around as I need them, okay? And so the first thing we want to do is we want to weigh out our metal sample. And so you have this balance here, and it's an electronic balance, and it has this button that's called tare. The tare button zeroes it out. So whatever is on the balance, once you hit the tare button, you're going to see the zero reading for your grams. So what we want to do is we want to measure our weighing boat. And so when you're dragging things over, you see how the dotted line went around the scale. That's how you know it's actually been added to there. And so we want to write down the measurement, the measured value for our weighing dish. So we have a mass of 5.978 grams. And when you're taking measurements, you're going to write down all the numbers, because all the numbers for a measured value are significant. They're important for that measurement. All right. And so that's the mass of that. So once you've gotten the mass and you've written it down, it says you want to tare it or zero it out. Okay. And then you're going to add the metal to it. So metal 1. So you want to bring the metal over until you see that dotted box around the weighing boat. And then you know it's ready to measure. We need a measurement, according to our instructions, of 3 to 15 grams. So there's two ways you can do: precise or realistic. So we're going to try realistic, and we're going to click the hold and pour button. And we get a mass of 11.13 grams that are here. So that's between our 3 to 5. And so we are good here. But we want to actually write down what the mass is on the balance right here. So it's 11.1279 grams. Remember, we want to write down all those numbers. And so once we've gotten our mass, we're going to set our sample aside, we could put our balance back up here at the top to get it out of the way, as well as our metal, because we're finished with that for right now. And now we're going to pour out water, okay? One thing I do want to mention, anytime you're writing down your measurements, you're doing calculations, all of that needs to go into your lab report. And so the measured values go in a table, and your calculations, you do want to show calculations in your lab report. So make sure that you're doing that. All right, and so now we want to get some water. According to your instructions, you want to have, wait till this highlights, there we go. You want to have 250 milliliters of water into your beaker. And so I'm going to click on the precise tab, put my 250, and then pour it, okay? And so right now I'm finished with the water container, but now I want to use the graduated cylinder. And so for the graduated cylinder now, this is a 10 milliliter. We want 2 to 7 milliliters of our water. And so we take the beaker, go over to the graduated cylinder. Let's try realistic, and we want to hold and pour. All right, so that measured a little bit more. It was 8.45, and we want 2 to 7. And so what you can do is right click on it, and we want to remove the liquid, okay? And so now we try this again, but this time we want to do precise. So let's say we put in 4.00 milliliters in there because we want to go 2 places after the decimal for this particular piece of glassware. And so we poured that in. So you're going to write that down, 4.00 milliliters, and that is your initial volume. So we're going to call that V sub I. V sub I is just the initial volume, 4.00 grams, all right? Milliliters. So we can move our beaker out of the way. So now we want to pour our solid into the graduated cylinder because we want to know what is the volume of our solid. So we're doing a method called volume by displacement. And so when we pour that in, we want the precise amount to go in. So we know that we measured 11.1279 grams. And so that's what we're pouring into there. So once we've poured it in, you see how the volume on the graduated cylinder increased. Now we want to read that new volume. So this we're going to call our final volume. And so we are measuring it by looking at where the bottom of this meniscus, this is known as a meniscus, and it's where the water forms what I like to call a happy face, okay? But it's the formation of the water because of its attraction to the sides of the walls of the container. And so it forms what we call a meniscus. To read this, you're going to read the bottom of the meniscus. So the bottom of the meniscus is right at the 5. But remember, we want 2 decimal places. Okay, so anytime it goes away, just to let you know, you can click on detailed view and it'll bring it back. All right, and so we want 2 decimal places, so we're going to write 5.00 milliliters. All right, and so we have our final volume, we have our initial volume, we have our mass of our sample. And so I'm going to show you how we would calculate the density based on these values. And so right now we are going to go to the whiteboard. So first we need to stop sharing this, okay? And then we need to bring up a whiteboard. Okay. Let's open the board, okay. And so now we're gonna take our pen and we're gonna write down what we have. So we have a mass, and the mass is given by the symbol M. So that is equal to 11 point, let's make that point a little bit more defined. Ooh. All right, so that was a little too defined. Let's look for our eraser. There's the eraser. Okay, let's go back to the pen. Okay. All right, so 11, that's supposed to be a point. All right, 11.1279 grams. And then we also have the initial. We're going to use an I for initial. And our V initial was 4.00 milliliters. And we had our V final. That's supposed to be an F. There we go. And our V final was 5.00 milliliters. Anytime we're calculating density based on displacement, the first thing we want to do is to subtract these 2 volumes to get our volume for the sample. And so our volume for the sample is going to be 5.00 milliliters, and minus 4.00 milliliters. We always want to do final minus initial. All right, and when we do the math for that, we get 1.00 milliliters. All right, now we want to calculate our density. So our density is given by the symbol D, and it's equal to mass divided by volume. And so our mass is 11.1279. That was the mass of our sample. And that's grams. G is the symbol for grams. And then we are going to divide that by the volume that we got after we subtracted, because that is the actual volume for the sample. So 1.00 milliliters. M capital L, lowercase m, capital L, that is the abbreviation for milliliters. So when we do the math for this, obviously anytime we divide by 1, we're going to have the same number. All right, so we have 11.1279, but we want significant figures. And if you recall, when you're dividing numbers, the number that has the least amount of significant figures is the significant figures for your answer. And so 11.1279 has 6 significant figures, 1.00 has 3. Because of this decimal, remember these ending zeros are significant. And so we want to round this number to 3 significant figures. So instead of 11.1279, it would simply be 11.1, and the units would be G for grams, and then you put a slash mark, and then you put milliliters. All right. And so you're going to do 3 trials for each of your unknowns, so that you can take the average of your 3 trials. And so I've shown you how to do one trial, and so you should be able to do the other 2, as well as look at the other 2 metals and determine their densities. If you have questions though, as you're going through this lab report, and as you're going through the lab assignment and typing up your lab report, please let me know. Thank you so much. Have a great day.